Welcome to today's lesson on graphing, reflections, and transformations. Goals for today. After this lesson, I will be able to describe the transformations given an equation, use the description to graph reflections and translations. So now, we've done a lot of work on communication or writing the descriptions on a graph. We always want to identify the parent function in our first function. We always want to locate the parentheses, what is attached to the parentheses, and then the variable. Okay, anything else that's been added to it is a transformation. So we have a negative on the outside. Outsides are vertical. So this is a vertical reflection. And we have a +3 on the inside of the parent. Insides are horizontal. We don't trust our horizontals, so this is actually a left 3 movement. So now our parent function is the x squared, so we're starting with our initial points, -2, -1, 0, 1, and 2 for the x value. When we square those through the parents, we get 4, 1, 0, 1, and 4. So now we want to start looking at the transformation and what do we do to the original values. Now, a vertical reflection affects only the y values, and it is a multiplier value. So we're multiplying by a -1 with our y values. A horizontal movement affects your x values, and to move the graph to the left, we're going to -3. And what we always want to remember is order of operations. Okay? Order of operations tells us we have to multiply first before we add or subtract. So I'm going to multiply all my y values by a -1. That's going to give me a vertical flip, and we'll also show it on the graph as well. And then all of my x values are going to be subtracted by 3. So -2 minus 3, -1 minus 3, 0 minus 3, 1 minus 3, and 2 minus 3. Okay, now that gives me my initial points for the transformed graph. So now, looking at the original graph of x squared, here are my 5 parent points. So if we think about the vertical reflection, a vertical reflection is an up-down flip. So anything that's above the x-axis has to flip below. We're keeping the distance the same. And then that point that is on the x-axis stays on the x-axis with that flip. So now I've performed the vertical reflection, and now I have to transform or move the graph left 3. So every point gets moved to the left 3 spots. And then what we can do is compare our table values to the graphical values we have with the movement. My center point is at -3, 0. The 2 points on either side are -4, -1, -2, -1. Okay, and then the one thing that we always want to do is complete the graph. Make sure that your x squared is rounded to finish the graph off. Okay, next parent function we have, we want to identify the parent, look for the parentheses in the variable, what's directly attached to it, because we only have our 5 parent functions. Okay, so we have 2 operations being done to this x cubed graph. We have a negative on the inside. We know insides are horizontal. So we have a horizontal reflection. We have a -2 outside the parent. Okay, outsides are vertical. Head shake rule tells us we trust what we see. So this graph is going to move down 2. Okay, now once we have the description, remember what variable is being affected. Horizontal is affecting our x values. Okay, we have a -1 multiplier, so even if we do the opposite and divide by -1, okay, it gives us that same value. So we always look at reflections like multiplication, okay, but if you want to think about it as the divide by -1, conceptually, that's on the right path. So we've got our down 2 movement. Up downs affect the y values. We trust the operation that we're doing. So it's our y values minus 2. So when we look at the parent function uses the same 5 x values, -2, -1, 0, 1, 2. The important part is making sure you identify where's the center of the graph and then showing what's happening on either side. -2 squared is a -8. -1 or cubed, excuse me, is a -1. 0 cubed, 1 cubed, 2 cubed. So now we've got the parent function. We can put those data values on the graph. And then we remember that we can mathematically do the operation, and then we want to do it on the graph, and then compare those two and make sure that we get the same answer. So our transform function, x values times or divided by a -1, gives us a +2, +1, 0, -1, -2. Okay, so I've performed the horizontal transformation. Now I'm going to perform the vertical transformation. My y values are -2. So -8 minus 2, -10, -3, -2, -1. 8 minus a -2 is 6. Okay, so we have those points. We know where the graph is going to end up. But now the next thing that we want to do is perform the operations on the graph itself. Remember, multiply first, then addition, subtraction. So the first thing that we have to do is a horizontal reflection. So we're reflecting over the y-axis. That 0, 0 point stays on the axis. The +1 point now flips over to -1, +1. Okay, so in this graph, it's very hard to notice the difference of a horizontal versus vertical reflection. Okay, but operationally, there is a small difference in that. And then the last piece we have is we're going to move the graph down 2. So every coordinate point gets moved down 2. And then we connect the values from there to finish out the graph. Remember, smooth transitions, we don't want to have straight lines that connect the dots. Okay, next two parent functions. You know, if you feel like you understand the transformation at this point, all I'm going to do is just show the process with our other 3 parent functions so we have a chance to work with each of those. Parent function, what operation is being done in the basic form to the x? We've got our absolute value parent. Okay, 3 pieces being tacked on to the parent itself. So if we first start by identifying the parent function, we're going to start with our same basic 5 points, and then absolute value is distance from 0, makes each value positive because our distance values are always positive. Our 3 operations, we have a negative on the outside. Outsides are vertical. So we have a vertical reflection. A -6 on the inside. Insides are horizontal. The head shake rule tells us we don't trust what we see. So this minus is actually going to move the graph right 6. And then we have a -2 on the outside. Outsides are vertical. Verticals we trust, so this graph is going to move down 2. Okay, and remember, when we look at the operations, once we describe it, we want to talk about what's actually going to happen to the table. Verticals affect your y values, so we can look at both of those verticals first. Our y's are going to be reflected, multiplied by a -1, and then move down 2. So -2, and we do have to follow that order of operations. Our horizontal x values, right 6 means that the x's are going to be plus, not times, plus 6 to our x values. So if we perform those transformations, starting with our y values, multiply by a -1 and then subtract 2. So 2 times -1 is -2, minus 2 is -4. -1 minus 2, -3. 0 minus 2. -1 minus 2. And -2 minus 2 for our values. Our x values are going to be moved right 6. So we have to add 6 to all of our x values. Okay, so we added 6 to all of our x values to move them to the right 6 spots. Okay, once again, we want to start with the parent function on the graph, apply the transformations. So first transformation we have is this graph has been vertically flipped over the x-axis, so anything that's up becomes down. The 0 point stays in the same position. And now our translations, we can do both of them at the same time. We're going to move them right 6 and down 2. 1, 2, 3, 4, 5, 6. Down 2. And then now we have our transformed graph for this situation. Okay, and then we want to go through and check some points. First point in the middle, 6, -2. And then we have 5, -3, 7, -3. Okay, so this is where you can identify and fix any small mistakes that you might have made mathematically when looking at the graph. Okay, our fourth parent is the square root. This graph is a little bit different in the parent function because we don't have any negative values because we can't do the negative of a square root. So we've got 0, 1, 4, and 9. Okay, we're looking for the perfect squares because we want perfect points that we can graph in this situation. Now the square root drops off. That is our parent function. So we have a negative on the inside, plus 4 on the outside. So we have a horizontal reflection. And it's going to be our x's divided by -1. Okay, let's just keep that opposite operation in mind. You've got a plus 4 on the outside, so the graph is going to move up 4. Or the y's plus 4. Okay, so we're going to perform this operation on our table, and then we'll move it to the graph. X's divided by -1. We've got 0, -1, -4, -9. Our y values are moved up 4, 4, 5, 6, and 7. Okay, now looking at the original graph, there's our original points on the graph. Starts at 0 and goes only in one direction. Horizontal reflection means that we have a right to left flip. So now I've reflected it, And then the last thing I'm going to do is move all of these points up 4 for my final version of the graph. Remember, it starts at 0, square root goes in only one direction graphically. And then now I can double check points. I can look at this point right here, negative 9, 7. Okay, verify it based on my table. I want these two pieces to connect overall. Okay, last graph we have, our most difficult parent function to work with, the 1 over x. So when we're building this parent, we start with our traditional values. We can include 0, so we want to include points that are close on either side. So this is the one parent function that needs 6 points to truly give you the view of the graph. So we've got negative 1/2, negative 1, so I'm doing 1 divided by my x values. So now I have the parent function. The 1 over x is what we've boxed, so we actually have a vertical outside negative and a +2, so everything here is going to affect our y values. We have a vertical reflection, or our y's times negative 1. We trust what we see. We're going to trust that multiplier. And then we have an up 2 movement, or our y values +2. So now we perform this transformation. We can do it on the table initially. Okay, we multiply by a negative 1, and then we add 2 to each of the values. And this one, since we're dealing with fractions, does get a little messier, but we want to work through our values. The x's weren't affected, so I copy those over. My y values, I'm going to multiply by a negative 1 and add 2. I'm going to change this to a decimal value then. So we had a positive 1/2 plus 2, positive 1 plus 2, positive 2 plus 2. So then we had our initial values. Okay, now when we go the other way, we multiply by a negative 1. Negative 2 plus 2 is 0. Negative 1 plus 2 is 1. Negative 1/2 plus 2 is 1.5. Okay, so these points are a little bit harder to graph. But once again, we'll look at the graph itself. Start with the original graph. Okay, it's a two-piece graph. Okay, it doesn't cross either of the axes. And then every one of these points is going to be first vertically reflected. So any points in this lower quadrant are going to flip to the upper quadrant. Any points in the upper right now flip to the lower right. So now I've performed the reflection, and then the last thing that we have to do is move all of these points up 2 to finish the graph. And that's where some of these graphs can get a little busy. So the more work you can shift to the table a little bit and then transform over to check, helps as well. So here's the first part of my graph. Remember, I can't touch those axis lines, and the axes move with your operation. Okay, so we have what we call a horizontal asymptote and a vertical asymptote, two lines that we cannot cross. But that is our lesson today for graphing reflections and translations.